Hi, good day. So this is the first time that I will be sharing to you via Google Meet the activity that one of my students prepared in the laboratory. So we did this asynchronously. I gave the instruction both synchronous and asynchronously for this activity, and it is named as Embryology of the Frog. I asked my students to get as many resources as they want in order for them to describe the process or the processes from which a frog develops from its embryo up to, I think, they gave me until adulthood of frog. But for embryology of frog, our focus is actually the embryo. Okay, so let's move on. So first, I'll be presenting that part, in our Google Classroom. Okay, so I think that is a window. Oh no, it is a tab. Yeah, okay. Okay, Embryology of the Frog, Lab Activity 2.1. So I'm giving credit to Miss Anna Bridget A. Alegre. She's one of the best students I had during my uh, first college teaching of zoology. So let's start. Okay, so unfortunately, this output cannot be converted into a video or slideshow at the moment. So I tried to make this using. I've tried to make this presentation using Google Meet, and I recorded this for you to watch. Okay, so here we start embryonic development of a frog. So I commented also that her presentation is cute. Yeah, so it somehow um, encourages us to watch or to delve into her presentation via the use of some images. Okay, cute images. So let's start with this bear circle. What do you think is this? Okay, so I'm hearing answers. Yeah, yeah, even though I cannot hear you. But actually, this is an egg. Okay, so what kind of egg? Look, you can see that there is already a distinguishing portion or part, right? So that distinguishing portion is a division from the northern and the southern hemisphere. But it can actually change depending on the movement of that thing or embryo. Okay? So the embryo is the fertilized egg. Okay? So there is the assumption that we already have the egg fertilized by the sperm. So we are talking about the frog, okay? Next, we have animal pole. So we also have here the vegetal pole. So these are the two divisions of this frog embryo. Next, development begins when sperm cell arrive and enters through the animal pole. Oh, so let me correct myself. In this part, we don't have yet a fertilized egg. So it's somehow different, right? Okay, so for this amphibian, we need to look at the animal and the vegetal pole first in order for us to check whether fertilization will occur. Okay, so the area where the sperm entered will determine the dorsal position of the development. So the rest of the development can follow. So this is the dorsal part, and the sperm will enter there. And tada! Okay, so this actually is the fertilized egg, as what I've mentioned here. Okay? Yeah. So for you to not be confused, for human beings, we actually have this already, even without after. I mean, we have this already after fertilization. But for frogs, we need to take note of their animal and vegetal pole. Okay, and the dorsal part will be the part in which the sperm will enter. Observe here. Okay, so there is already something which is changing, and that is at the division or the equatorial part of the two hemispheres or the two halves. Two cell stage. We have the gray crescent. So we call it the gray crescent now. Okay, so what is this? When the fertilized egg rotates 30 degrees, a light colored chiroplasm, sometimes it's cryo, so let me check again, is exposed, called the gray crescent. It determines dorsal position of the zygote. Again, the zygote is the fertilized egg. That is the term referring to the fertilized egg. Wow. So look at this. We actually rotated the sphere. Now we have the two-cell stage or the cleavage. The zygote starts its first division after 3 hours. It's some kind of different from the fertilization of human beings, okay? Cleavage, division of the zygote, beginning of blastulation stage. So what's that blastulation stage? Two-cell stage and there forms blastomere. Okay? What's that? Four-cell stage. Four-cell stage. So blastome meaning formation of more cells with some holes, okay, or parts in which there are more cleavages forming. Okay, for some we have this what we call blastocyst. So it's something like a hole. Okay, a hole. Let's move on. 16 cell stage and 32 cell stage. As you observe, one cell divides into two, and then that uh, that sister cell will again divide into two. We call it cell division, right? Okay, now we have the morula stage in which we have a ball of blastomeres already. Morula stage, a ball of blastomeres. If you want to know the number of cells, you can do your math, okay? You can do your math. So it's like an exponential growth of cells. Micromeres, we also have macromeres. What are the differences on this? Basically, it tells us about a certain part or certain half which has small cells and the other one has bigger cells. Blastula stage, formation of small fluid filled cavity called blastocells. Okay, okay, cell layers are differentiated. So when we say differentiated, some will become the ears, some will become the nose, some will become the brain, etc. Ectoderm, blastocele, gray crescent, also the mesoderm, and then the endoderm. We will tackle this more or in detail when we talked about the different organs of the body. Okay, after the tissues, we have the organs. So they came from this germ layers, okay, germ layers, the ectoderm, endoderm, and mesoderm. Gastrulation, rearrangement of blastula to form three layers of cells called germ layers. Gastrulation, three layers of cells called germ layers are formed. So we are just reiterating what I've explained earlier. Okay, you can just read this, the endoderm, ectoderm, mesoderm. Yeah, so we have the internal organs, nervous system, skin, muscle cells, internal organs, and connective tissues. So take note where these organs are coming from. Okay, which germ layers? Ectoderm, endoderm, gray crescent. Okay, similar photo as to the previous that we have seen. Beginning of gastrulation, a gastrula is formed and cells migrate towards it. Remember that differentiation is happening in this stage also. This stage of gastrulation is known as epiboly. Ectoderm, again, endoderm, mesoderm. Blastocele slowly disappears and is being replaced by a new formed cavity called the gastrocele. Mesoderm, look, there is a color coding already to signify that there is a change already into the cells. Blastopore, blastocele, archenteron, also gastrocele. There are different terminologies which are referring to the same part or the same what do you call that structure. Emboli stage of gastrulation, the blastopore keeps getting smaller. Involution stage of gastrulation, late gastrulation stage, yolk plug. So as you can see, we have the yolk plug for common eggs, which are covered in shells. You see that the yolk is at the middle portion of the fertilized egg. So this is after 42 hours already. And these are the references. This is the end of this presentation. So thank you for listening.